I am a creator. Blending art and technology. I am a creator to immerse our senses. Blending art and technology. I am a healer, helping us take the next step, a creator to immerse our senses and see what's possible. Blending art and technology. I am a healer, helping us take I am a pioneer to immerse our senses and finding life-saving answers. Blending art and technology. I am a healer and pushing and watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere. I am a creator. Blending art and technology. To immerse our senses. I am a healer, helping us take the next step and see what's possible. Helping the earth breathe easier. And watching over it for generations to come. I am a storyteller. And bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Okay, good morning, everyone. Welcome. So today I welcome all of you to our webinar NVIDIA series number 2. And today's topic is NVIDIA Metropolis SDK and Toolkits for Intelligent Video Analysis. So during the webinar, feel free to drop the question on the chat with format name, university, email, your question. Also, toward the end of the webinar, attendance form link will be provided. So before we're going into today's main session, allow me to introduce today's speaker. Our speaker today is Mr. Chong Quang Hui, an NVIDIA engineer. Mr. Chong has over 8 years experience in vision AI and edge computing, where he is focusing on solution architect and IVA engagement covering Asia Pacific regions. He has a bachelor degree in electrical engineering and currently pursuing a master degree in software engineering. He also holds a project management professional PMP certification. We also welcome our honored guest today, Mr. Dr. Etikan. So thank you for joining.
Sure.
So, all right. So without further ado, Mr. Chong, the floor is yours.
Yeah. Yeah, certainly. Thanks for the introduction, Lina. And Chong will start presenting on the IVE. But before we start the presentation, what I would like to address to the team here, audience. So we hope after the previous presentation that we did in terms of Nemo and Riva, the researchers, the developers, the students, could able to go and download and try those SDKs and platform so that you can use that for your project in terms of final year project or in terms of your industrial research work or industrial attachment that you may do with industry. You can experiment that. You can even do it at home just for you to try and so forth, or you can actually work on a joint problem among your friends. So similarly, today's talk is going to cover intelligent video analytics and related toolkits. So there could be a deep stream will be introduced. There is a Tau toolkit will be introduced, and so forth, where similarly you can download the models from NGC for you to try. So what I wanted to emphasize is, after the session, I would like you to go and try, these SDKs and platforms that's made available for you. There is a models available for you. You can use the model that we given by NVIDIA, and at the same time, you can bring your own model. You can actually download from different sources as part of your research work, your master's or PhD work, or your undergraduate work. You can actually use this, the tools and libraries and a framework as a base platform, a jumpstart platform, a launchpad platform for you to do sandboxing very quickly, to prove certain concepts and move forward with implementation. Right. So your activity post this presentation is very important. Go back and try, do project, do a lot of hands-on work. So with that, I'll pass it to my colleague Guang Hui to take it from here to do the presentation. Thank you, Lina.
Okay, thank you. Yeah, thank you, Lina. Thank you, Etikan. So right now I will be giving the presentation like what just now Etikan mentioning. So there are a lot of SDK tools and also the resources that you guys can utilize. But then the most important is to have a tryout on all these tools and then get the hands-on and practice so that you get familiarized with all the things. So let me get started. Let me share my screen. Can you all see the slide now?
Yes, we can see it.
Okay. So let me get started. So today I will be sharing the NVIDIA Metropolis platform. So this platform is basically mainly focusing on the intelligent video analytics in the smart spaces. And then we have a lot of SDKs, toolkits, and also the resources being here. So today, this is our agenda. So the Metropolis overview and also the some of the SDK and toolkits. Like I will share the first one is pre-trained models and also the TAO toolkit. And then we have a Distream SDK, and then with a Triton inference server. And also there will be some resources and also the summary that you can get all those information. So let me start with some of the marketing things. So this one is to on the AI revolution. So for the AI revolution, there are a lot of AI application implement in the smart spaces. So how do you measuring and managing all these physical spaces are really important, because when you have a monitoring on how is it in a public space like currently in a COVID situation, right? This really help you to get into the cities or the traffic or the retailer side even safer, and also fully utilize all the stores. So how this experience and the process going through one place to another is really important, and also getting better with the AI adoption and implementation. So as you see here, there are some of the use cases like the traffic management, the retail side, and also the factories, that it helps the humans to have a better life and also better lifestyle in their all these smart spaces. And then this one, the industry is continuously growing with all the AI implementation over all these spaces. Okay, so I wanted to share some selected example here to let you guys know about what is it about with the intelligent video analytics. What does it do? So I would say in terms of computer vision, basically they are mainly on three parts, like the image classification, the image detection, like you are seeing here with some videos that showing some of the detection of the vehicles, and also classify what kind of types of these vehicles, and then also doing some segmentation. So another part on this one is a segmentation example. So how does the image using for defects detection at the edge? So this is to detect the winkles, to detect the bottles, whether there's a winkles happen there. So you see there's a winkles, it was highlighted it in a green color, so that they know the defects happen, how much of the defects happen with the manufacturing of the bottles. So this is the part that some of the computer vision and video analytics use cases can be in the smart spaces place. Okay, so so by doing all these use cases and having all this development and also the deployment of this video analytics and computer vision, right? So definitely by doing this, it's not just one day can build up everything. So there are a lot of challenges and also the key things that need to take care when developing vision AI projects. So these are some of the challenges that we seen in the market. So one of the thing is, how do you create a highly accurate AI models? So for video analytics and all the AI deep learning parts, right? So there are two key things. One is the training parts, the model trainings, which occurs when you need to train to have a very high accurate AI models. Then another part is when you do the deployment. So the deployment part is more on the model inferencing. So the training parts and the inferencing parts are both important when you are doing an end-to-end AI application adoption. So another part is, how do you achieve a high throughput when you have a deployment at the edge, or you have a deployment at the data center, the on-prem server. And then another part is deploy at a scale. Let's say you have millions of camera, how do you manage it with large scales? So these are some of the common challenges So in today's, we have this NVIDIA Metropolis platform. So at the bottom layer, you see here, this is our NVIDIA EGX hardware. So we have all the edge devices and also the EGX server. The edge devices, the Jetson families, and also we have server type, the on-prem data center use servers. And then on top of it, for the framework, we have NVIDIA TensorRT and also NVIDIA Triton Inference Server. So today I will be mainly sharing about the whole NVIDIA Metropolis software stack, the pre-trained model, the TAO toolkit, and also the DeepStream SDK. So these are all the sharing that will be shared today. So for the pre-trained model, TAO toolkit, DeepStream SDK, and also the Triton Inference Server. And then we also have NVIDIA Fleet Command. So this one is mainly for the device management. So let's say, like just now I mentioned, you need to manage large scale of the devices. How do you manage it efficiently, and also have a high security stack involved in all the edge devices? So all this is a full stack of the NVIDIA Metropolis. Okay, so like just now, I've mentioned some of the Metropolis SDK and toolkits with the resources, right? So these are the chain that the developer solving the industry problem classified by each of the role here. So they are the training parts, which you will be utilize the TAO toolkit and pre-trained models. And then in the inferencing environment, the development into a production-ready environment, you will use DeepStream SDK. So different role covering different kind of responsibility for all the AI end-to-end production pipeline build up. So let me get started with the training part first. So in terms of training parts, we have a TAO toolkit and also the pre-trained model that ready for the developer to utilize it, and then they will get some benefit on training their data and also get the production ready pre-trained model and then using it for deployment. So what does this TAO toolkit do is it's mainly on doing the transfer learning. So the transfer learning is actually a process on transfer learn on the previous, I would say, previous trained model, and then to customize into your own data set. So you do some fine tuning. So the key benefit of this transfer learning is to you get less data required to train accurate models, and then also reduce the total training time and also the cost. So for the TAO toolkit framework, we have the pre-trained model together with the TAO toolkit. So we are setting up to solve every one of these problems for developers from large scale or small scale. So we have created an end-to-end workflow. So we have a NVIDIA library. We have a NGC. Later, my next slide will share a little bit about what is NGC. So inside our NVIDIA library, the NGC, you actually get to access a lot of NVIDIA optimized models architecture, like all those common one, efficient net, ResNet, the YOLO v3 and v4. All this is a optimized build architecture within NVIDIA platform. And then we also have NVIDIA pre-trained models. So this one is a custom built pre-trained model. So it's developed by NVIDIA. So all this, you will see some of the models like PeopleNet, gaze detection, then post estimation. All this is a customized build on purpose pre-trained models. So later I will share a little bit on what are those models that available that you can use for all these pre-trained model. And then you are using you are taking all this pre-trained model and then with a TAO toolkit with your own data set, then you do some fine tuning. So you train and then adapt it and also optimize. So optimization part is where you once you have a trained model that you think the accuracy is enough for your deployment, then you can do some optimization, like you do some pruning that you reduce some of the zeros layers, and also you can do some quantization that converting from FP16 or FP32 into IN8, so that you can quantize it, become a smaller models, and then you can have a higher throughput when you're doing the deployment. So this is a end-to-end pipeline for you to developing the from the training side to the inferencing. So lastly, you can deploy all these pre-trained model into our SDK. So we have a DeepStream SDK that I will be sharing later. So, and then we also have Riva and Triton. So some are, Riva is mainly for the analytics on speech recognition, all this. So today we will not cover this. So mainly I will covering the DeepStream and Triton for the SDK. So this is about the NGC. So this NGC you can treat as a cloud repo that we have a lot of tools, resources, pre-trained model containerized inside this NGC catalog that is easy for all the developer to try out, because everything is containerized, that you can just pull it out and then you can get access into all these container image, and then you can try out all the toolkits available, like DeepStream SDK, Tau toolkit. With all this pre-trained model, you can actually pull the container to try it out very quickly. Yep. Okay, so this is about the high performance pre-trained vision AI model that I have highlighted just now. So we have more than 15 plus of the custom built pre-trained model, which all are optimized for high throughput, trained for more than 80% accuracy. This one is production ready, but then we encourage our developers to fine-tuning it and then train with your own data set, so that you can get a better accuracy based on the detection of your object and also the target object of your training. And then this one also adaptable with our Tau toolkit. So it's pretty simple on using it from the end to end. And then let me share some sample of what are those pre-trained models are. So this is the PeopleNet used for real-time inferencing performance on detect person, backs, and also face. So at the left-hand side, you can see some of the performance that you are getting. So it's an amazing performance that you get, because we have training it with 750K frames, and also we are continuously optimize these models. And then currently you will be getting the performance at the left hand side. The for let's say you are using a T4 hardware, so the performance you are getting is 1400 plus, compared to using ResNet as a ResNet 34 and also ResNet 18. So these are the backbone that you can choose between, and then these are the frame per second performance that you are getting from this graph. And then we also have PeopleNet, and then the next one is a face detect IR. So this one is can be a good use case if you're doing some behavior detection for especially using IR cam. So this is some of the performance that you are getting. The accuracy is 96 plus, and then also the frame per second you are getting by using a T4 card is 9720. And then we also have others model, right? Dashcam net. So it will detect cars, person, road sign, and bicycle. So with accuracy and also the traffic cam net. So we have a lot of models, pre-trained models, custom built for you to directly using, or you can fine tuning it with your own data set, because all this we already trained with a high volume of data set here as shown here, so that you do not require like 100K of data to training from the scratch. You just use your own data set, maybe like 10K, 15K to retrain it to get a better optimization of your data set to have a higher accuracy. Okay, so these are some of the benchmarking that I wanted to show. And then there's a video demo here. So this is a video demo by implementing using a dashcam net and also the vehicle type nets for detection, and then and also detect the vehicle type. And also this one is with a traffic cam net with a vehicle net. So this one is to detect what are the models of the vehicles and also the detection part. Okay, so this is what I have shown in the early, that once you have your models trained with your data set, and then you get a higher accuracy. So you are satisfied with accuracy that you are getting for the model. The next step you are doing will be to make it inference ready. I would say inference ready model that can be used for deployment. So this is one of the things that you can do is a quantization aware training. So this is a second layer of training after you are satisfied with your own data set and also satisfied with the accuracy that you are getting. So this is the workflow here. So after you train with your new data set, the next one is you do a pruning. So you remove all those zeros layers, and then so that you can reduce the size of the models. And then after that, you do a quantization, retraining it to influence deployment condition. So this is the performance that you are getting after the quantization. So the baseline is what you get from training. So from training part, you are using a higher precision because you need to do a backward propagation and then training it for many times. And then after that, you satisfy with the accuracy, you do a pruning for that. After you do a pruning, you retrain it with a quantization aware training, so that you can retain similar trainings accuracy, but yet you get a smaller size. So smaller size of the model size, so that you can have a expectation of the higher throughput compared to using a FP32, because you are actually lower down the precision, and then you are still getting the same kind of accuracy. So this is what I want to share on the QAT. And then the other part is the implementation together with the DeepStream. So the next topic I will be sharing is the DeepStream SDK. So this one is to implementing the end-to-end AI pipeline using the DeepStream SDK together with a train model. So after you train your models, you will get a file called .tlt or ETLT that you can use it directly into the DeepStream SDK and then run the whole pipeline of the AI application. So these are all some of the benchmarking that are running inside the DeepStream with our models, the PeopleNet. All these are with you can have a reference on the resolution, and also these are all the frame per second that you will be expecting when using the DeepStream SDK together with the pre-trained model. Okay, so let me jump into the next topic, the Distream SDK. So what is the main purpose for having this Distream SDK is the Distream SDK actually bring in the huge plugins that available for the developer to utilize, so that you do not need to build any pipeline or your application from the scratch. So all these are the plugins. So this is based on the GStreamer open source. On top of it, we actually built this Distream SDK as all the plugins level, so that the developers can quickly build up the pipeline from end to end from the data ingestion to the result. So we have 150 plus plugins and continuously increment all these plugins inside this Distream SDK. So for normal video analytics pipeline, so you will have sensors, which is the cameras, that you are getting the video stream from the data input, can be H.264, can be H.265 as a data ingestion. After you capture all this data with a video stream, you need to do a decoding. So capture and decoding. So all this is in a plugins manners that you can use all these plugins with configuration file. So it's a concept of a GStreamer that adopt into the Distream SDK. So with all these plugin, you just need to configure the data ingestion, the decoding format, all these things. Then you can run the whole pipeline. So from the left side, the camera ingestion, the decoding, and also after that, you come into the pre-processing, that you pre-process all this decode data, and then maybe do some resizing or do some cropping. All this you can run with pre-processing plugins. After that, this is where your pre-trained model using for is you can do a AI inferencing for detection, classification, or even segmentation, all this. Then after that, you do trackings, business logics, analytics, and also the composition. So all these come with a plugins module that you can use, and then you just need to configure and then to run the whole application pipeline. Okay, so all these are hardware accelerated. When I say hardware accelerated, is already optimized with our GPU when running all these plugins. So you will see a great performance and amazing performance when you are running with your trained model together with this AI pipeline. Okay, so this is what is new about Distream 6.0. So for the previous Distream 5 and 4, all this we only supported on the C++ and also the Python code for interface with the Distream SDK. So in Distream 6.0, we actually included another way of using our Distream SDK, if the Graph Composer, which is a UI based that you can drag and drop all this module or the plugins, and then you align it as your total AI application pipeline. So, and then after that, you compile and running it in a full scale. So this is another additional ways of running the Distream SDK. And then for the new parts in 6.0, we actually also included some of the new models that are ready to use. So so because when all these new models coming in, you actually need to handle all these post-processing part. So all these post-processing plugins and module we also added into the Distream SDK that you can ready to use, and then use it for your deployment. So all these include all these models and also like action recognition net to detect all this behavior action, and then post estimation, gaze estimation, and also we even include ASR, the speech recognition, all this. And then we also have a state of art trackers, which is our MVDCF. Later I will have another slide with showing the performance that you will see, which we are doing the tracking and also re-ID after being blocked by the obstacle, all this. And then for 6.0, we also have a new communication protocol, the gRPC, which allow you to communicate with a Triton inferencing server. And also this gRPC protocol is actually having I would say better latency if you're comparing to a REST API or HTTP that you are running for your communication. So this is the one of the thing that we also included both way, the DistStream with a gRPC and also Triton with gRPC. And then RiverMax support. So this one is to optimize the uncompressed data pipeline instead of going through from the network port to the when you have incoming packets or the data input, instead of going through CPU memory to GPU. This one allow you to directly from the Ethernet to the GPU to reduce the latency in between. And then we also have add in more libraries for IoT and also cloud use cases like MQTT, AWS Green Grasses, Redis, cache memory, all this you can utilize on that. Okay, so because for implementing DeepStream, there are in AI pipeline development, so there are a lot of complexity also and challenges when you are deploying the pipeline. So that is the reason why we have this DeepStream SDK as all the plugins module that you can use it directly. And then because these are all the challenges that the DeepStream SDK wish to tackle. So because you have multiple different kind of frameworks and also very diversified of language and also the framework that we'll be using for DeepStream SDK, because we are focusing on such a model can initiate on a public model zoo, or you can use you can use our pre-trained model, and then all these models can be directly implemented into the DeepStream SDK. So you do not need to have train from the scratch from TensorFlow or PyTorch. You can directly use our pre-trained model, implementing it directly to the DeepStream pipeline. And then multiple other kind of challenges like the total cost of ownership, because when you need to build everything from the scratch, definitely you take a lot of time and cost, and also training of accurate data, all this. So these are some of the challenges. And also this one is a one code base for multiple targets. So once you have this DeepStream SDK developed on your pipeline, you can run it on edge with our JSON hardware, or you can run it on Prime with our EGX server. So it's easy porting into all these targets or the environment. So this is the developing with DeepStream, I would say the building blocks. From the building block size, you get to have different ways of accessing it, developed in Python. So we have a Python binding on top of each of the plugins layer that you can interface with your Python code. And then you can develop in a C++ or C language for all these plugins. And the last one that I have introduced earlier, that we also have a graph composer in DeepStream 6.0 that you can utilize on your developing your pipeline for your application. And all this after you wish to have a deployment, application deployment as a skill, you can containerize your builder and then run it into different target environments. Okay. So this is the traffic tracker that I want to share. I'm not sure why this is not moving. Okay, yeah, great. So this is detecting the white car here. So later you will see the performance of tracking the car. So in between you see there are some blockings from the other cars that already block the targets. So this is our NVDCF tracker. What it does is we use the visual similarity to track the white cars, even those this one the car is being blocked, but it enable the re-ID to re-ID back the similar car that it understand this one is within the same target. So this can be used in a lot of space, like you are doing a tracking of and also people counting or vehicle counting, because vehicle counting sometimes is not accurate because a lot of blocking happens. When it block, it becomes a new target and then it counts as a new object. So with this trackers, you can actually retract it back with the same target for this. Yeah, this is just one of the example of the use cases. Eventually, this can be implemented in a lot of other use cases. Okay, so this is the pipeline that I was sharing just now. So a lot of time that okay, a lot of times that when you have okay, a lot of times when you have why this is keep moving. Okay, so here you can see that you're capturing the data ingestion, and then after that you capture the data from a CPU to GPU memory, with you getting the video streaming input. So this one will just, sorry, let me reshare the screen. I think can see my screen.
Yes, we can see your screen.
Okay, great. I'm not sure why this slide is keep moving out. So basically this slide is just wanted to share that instead of copying the memory multiple times from CPU to GPU, right? So this one, the GPU, the frame and also the buffer will be shared, will be saved into a shared memory within the GPU. So every time you do an inferencing and also other pre-process decoding and also the batching, all is using the same memory path that you can use all this data. So this actually reduce the latency from keep on copying from the CPU to the GPU side, and also reduce the workload for the CPU. So another part that I want to share is the decoding. So this one is the decoding that you can expecting when you are using the DeepStream SDK. So for DeepStream SDK, we have a NV decoder that when you're getting the data video stream input from the CPU side, so you can decode it with our GPU. That for T4 you can expect a H.264 H.265 1080p resolution, 30 frames per second. The decoding performance is like 84 stream. the camera channels that you can use for decoding for the T4 hardware, and also others are all those JSON card performance. Okay, so this is the DIStream software stack that I have shared just now. So on the bottom layer definitely can be targeted any of our NVIDIA devices like JSON, Tesla, or EGX server, and then all this inside the DIStream SDK also come with all this CUDA TensorRT inferencing engine. Also can communicate with Triton inference server, and also DIStream SDK also come with multimedia libraries that you can use for some of the pre-processing purposes. All these plugins are available for you to use, and also the decoding. And then all these plugins are hardware accelerated with our GPU. And then you also have a bidirectional IoT messaging like what I have shared, the MQTT or the AWS green glasses that you can communicate with. And then for the on-the-air model updates, so you also can use DIStream SDK for on-the-air models update. All these DIStream SDK, one of the easier ways for you all to test out is using our NGC. That is a repo that I have shared that you pull out all the container image with the DIStream SDK. So inside the DIStream SDK, there will be some reference application, the sample code. So a few sample codes that you can try out and then have a testing from a simple hello world pipeline to a complicated multi-stream mode application. So you can try out with all these samples. And also another part that you can do with DIStream SDK is you can create a Helm chart for easy provision of your environment in the future to all the others targets environments. So this one we have Python support, C++, and also another way is using the Graph Composer. Okay. So let me go into the next slide. So this one is a Triton inference server. So later I will share how do you form a pipeline between the end-to-end from the training to DIStream, and how DIStream communicate with Triton inferencing server, and what is the purpose on using Triton and DIStream together in some of the use cases. So for this Triton inference server, this one is actually provide you the flexibility of inferencing. So when I say flexibility, is because you can directly run all these native TensorFlow or PyTorch or even Onyx framework in this inference server, using it for the inferencing task. So this one support multiple framework, and then also come with a standard HTTP, the REST API protocol, the gRPC, and others C++ communication. So all this can be used to communicate with your backend environment or using gRPC with DIStream SDK. So for inferencing wise, we will have a scheduler that allow you to inference on a GPU or a CPU. So you can configure it whether you want to run this model inside a CPU or you want to run in a GPU. So you maximize hardware utilization for all the models, and also with different type of frameworks that you have. And then this also support different types of queries. So real-time batching, stream, and also Ansible that you can run within the Triton inferencing server. Then maximize the hardware utilization, like what I have shared just now, that you can run on CPU or the GPU. And then you also can run a dynamic batching that you can maximize the throughput for your AI application use cases. So beside that, Triton also designed for DevOps or MLOps. So this Triton can be integrated easily with your enterprise or your backend environment workflow, so that you can apply the AI use cases with your others application. So this Triton also with Kubernetes integration, that you can containerize it in a microservice, that you can orchestrate all these different microservices with Kubernetes. And also you can use a Helm chart for fast deployment within it. And then for the ML ops parts, you also can do it with do your own configuration to create your CI/CD pipeline, so that you can run DevOps kind of model updating, and also the workflow of the pipeline. And then this one is open source, so this is available in GitHub. For testing, you also can use the NGC, which contain the Triton, that you can pull it out and then have a quick testing for that. Okay, so that's a summary that I want to highlight. So for summary, we have just now covered the training part, that you can utilize our pre-trained models that are already trained with a huge data set. And also you can fine-tuning it with a toolkit, that you can build accurate AI models based on your own data set. And also you get the benefit on to create inference ready or production ready models, which the toolkit also include some of the features like pruning out all these zeros layers, and also the QAT, that the quantization or aware training, that you can eventually reduce the precision from FP32 to IN8, but not reducing too much on the accuracy. Then for building your AI application, once you have the train model, the training part, that's come with inferencing side. So for inferencing side, you need to build your AI application pipeline. So for this building pipeline, you can utilize our DStream SDK. So it's where you can use all the available plugins and then configure it and compile and run the whole pipeline for this application. So this one, all this can be fit in directly with your pre-trained model or trained model into this DStream SDK. And then for deployment, you can use a Kubernetes for easy for mass deployment, containerize all your all the application workflow, or you can containerize as a microservice that you can easily orchestrate by the Kubernetes for deployment at a scale. So this is the end-to-end use cases that I have shared just now. So with the NGC, you can pull out all this pre-trained model with the toolkit to train with your own data set. Once you have a production ready models, you can configure it inside the DStream SDK for AI inferencing. Then you create your own pipeline with all these plugins available with DStream. Then in between, you also can use the gRPC to inference with Triton inference server. So let's say some of the use cases, instead of creating your own customized plugin within the DStream SDK, you can feed in the data from the DStream SDK to Triton, so that you can get the flexibility to run some of the native TensorFlow code or the PyTorch code, that you can run the inferencing, and then getting back the result back to the DStream SDK to further running it. or you can get to select to send it back to your backend using REST API. And then some business logic that you can use a message broker, the publish and subscribe blocker that you can get all the output that you are interested with all these message broker available. And then after that, all this pipeline you can containerize and then easy for build up. Okay. So these are some of the resources that are available for all the vision AI models, the TAO toolkit and Distring SDK. So we also have a forum that if you are encountering any issue, that you can post your issue over there based on different topics. So if let's say you are having some issue on a TAO toolkit, you can post it at the TAO toolkit topic site, and then you can share your issue over there. And we have thousands of engineers at the back who supporting you guys on all this issue. And then this SDK, all this we have all this documentation and also the NGC available, the resources, webinar tutorial for you to have a reference on all this. Some of the others developer resources that you can get is like we have blogs writing for action recognition, and then we have a news on all these news update on all the latest version, and also the update features for all these SDK and toolkit. And then we also have Deep Learning Institute that you can get to subscribe and then to learn some of the step-by-step for all the toolkit and SDK. And then videos, source code, GitHub source code, all these are available for you to get started with our toolkit and resources. Okay, I think that's all for my side. Yeah, thank you everyone. So I think the next will be open for Q&A, right? Yeah, Lina.
Yes. So
Okay, back to you, Lina.
yep, thank you.
Okay.
So feel free, everyone, if you guys have any question, feel free to raise hand if you want to ask the question directly, or if you want to drop the question on the chat box, feel free to do it so. So I guess while waiting for the question from the participants, I guess I have a quick question. So I tried to install Dipstream like yesterday or a couple days ago. And then I noticed that the newest Dipstream version is 6.0, right? And then
Yep.
according to the documentation, it seems that we need to also install CUDA.
Yes.
And then the newest version of CUDA is 11.4, but on our A100 is we have it 11.4. Would that matter at all? Or do we need to install the newest updated CUDA version as well in order to install Dipstream?
Okay, so there is a documentation who listed out the dependency, because there are quite a numbers of dependency and library that you need to install. So there are a few ways for you to better try out. It's one of the way that I mentioned just now, the NGC, that you can pull the container. So that this one is you have all the dependency environment for you readily to try out inside the container. So this is a faster way that you can try out. Instead of installing everything from your bare metal, right? You can pull the container to try out. Then another thing is that for a start, actually, I recommend all our developers to use the latest one, because the latest one, actually, we do some optimization in between. So because you guys are newly start, right? To newly start from scratch everything, it's better to get everything in the latest, so that because there are some optimization and also some I would say the bug fix countings with the latest version. So to be safe, and also the easiest way is to upgrade everything to the newest version if you are installing in the bare metal. But if you want to have a quick tryout, you can use the NGC to pull out the container.
Okay, sounds good. Yeah,
okay.
because we also tried to pull it from container from NGC, and then we encounter some problem and then some errors like no publication key. So we're still figuring out why. So maybe we're missing some dependency.
Okay. Publication keys. Are you able to already pull out the container? Already pull the container with your environment, or haven't yet? It's an NGC key issue.
Yes, so I think so the way we did that was we went to NGC, and then there are some demos as you mentioned, right? So we just pull the tag and then try to run it. And then after that, we encounter some errors. Oh, actually, there's a specific one that we tried yesterday. And then when we went to Jupyter Lab, and then when we tried to run it, the pipeline, it says doesn't want to roll, something like that. So probably.
Okay. Yeah. So probably one of the way, because right now I don't see your specific error message. So one of the best way is you can post the question in the forum. So we have a developer forums that you can share your issue over there, so that they will know what kind of issue that you are facing with all this application. Yeah, since this is our own sample, yeah, should be pretty straightforward. Yep.
Sounds
okay.
Yeah, we'll do that. We'll do that.
Okay.
Thank you. Okay, everyone. Anyone has any question over here? Feel free to drop your question or raise your hand. Let's take a look if anybody. All right. We have one question over here.
Okay.
It's from Ahmad Alfan from Telkom University. So the question is, we saw previously about DeepStream can only run on certain machine with GPU or special processing unit like in Jetson. Can we run DeepStream on CPU only machine?
Okay, so like I shared just now, because our DeepStream is actually doing some of the hardware acceleration with our GPU, like the decoding you are seeing, the decoding actually expecting you have a GPU for running it. So most of the pipeline except the stream pooling, right, can be run on a CPU, but the AI application are mainly built for the GPU adoption. So it's better. I would say for running it is best to have the GPU inside the pipeline, because all these are hardware acceleration. Yeah. So it's tied with GPU resources.
Sounds good. So yeah, it seems in order to run it effectively, then we need to run it on the GPU machine.
Yes.
Okay. Any other question?
Okay.
Any other question? Anyone else? Let's see if anyone raised their hands over here. No one yet.
So you guys have actually tried out some of the SDK and also the toolkit before, while waiting for others to.
Yeah. So personally, we just tried. Because we own like a 100 station, so we tried, and then I think we just tried. We tried when we purchased it, and then yesterday we specifically tried to run the DeepStream. But we encountered some problem, and then finally, remember we have NGC, so we went to NGC and then took a look, and then we saw some demos, and then we tried to pull tag to run the demo, but it seems we on the step number 13 or something, we got stuck when we successfully went to Jupyter Lab and then ran it, but on the step number 13, it just said pipeline does not want to enroll, something like that.
Okay. So I think should be some minor issue. I guess could be
probably.
Some,
So I guess we should try to go to the forum probably.
Yeah. You can, because sometimes forum also can be a resources for you to find your issue. Maybe someone with a similar issue, right? So you can know the things. If you don't see any similar issue, you can just post it over there. Then there will be someone to answer your question. Yeah.
Yeah, because before we went to NGC, we tried to like install it like one by one, not like
Mm-hmm.
the full package. And
Yeah,
then some error, no publication key when we try to update, when we try to upgrade. So, oh yeah.
Okay,
So yeah,
okay,
we're still learning.
okay,
We're still learning.
okay, great, great. Yeah, so I think you guys have tried this stream. How about Tau Toolkit? Have you guys using it?
No, I haven't. Yeah, we haven't.
Okay, okay.
I haven't tried the
Okay,
toolkit yet.
okay.
Yeah.
Okay. Yeah, the Tau Toolkit is mainly on the training side, right? So if you are using it for training, you can get all these pre-trained models and then train with your own data set to further fine-tuning it. So, and also, I think that when you are using the D-Stream pipeline, we actually feeding in some of the pre-trained model from NGC. This is basically the pre-trained model that I have shared just now, some of the samples.
Sounds good. Sounds good.
Yeah.
Okay. Anyone else any question? Kalau mau nanya silakan, boleh pakai bahasa Indonesia. Kita bisa bantu translate. Ayo, jangan malu-malu. There's no such thing like a stupid question or silly question, right? So because we're all here learning, so feel free to ask any of question. Yeah.
Yeah.
Any question? So, Mr. Chong, so in your opinion, you've mentioned like some of the best practice for installing DeepStream, like installing the newest version and then running it on a GPU machine. Any other thing that you think we should be aware of?
Yeah, I think one of the thing that I recommend is the quickest way for you to hands-on, right? Because you want to hands-on is using our NGC resources. That is the best way. And then if you are using a bare method, definitely because since you guys haven't have any previous production environment before, everything should be in the latest will be the best. Then after that, GPU resources definitely require for all this stream, I would say. Then I would say that something that you guys can also referring to is we also have a news and also the blogs that someone actually do some sharing on the step-by-step on using Tau Toolkit or DeepStream SDK. So there are some minimum code there, and also because those are from our NVIDIA developers, right? So sometimes they also share some best practices. So the best practices that you can see what is the step they are running, so that you get to familiarize what to do first, what to do next, something like that. Yeah. So I would suggest that all these resources you guys can take a look. The news, the blogs. We have NVIDIA blogs that are available. And then the forum. Yeah, the forum is quite useful, I would say, because a lot of times, even myself also as a dev reviewer, I also go into all this forum to see some of the great work that others community do. Yeah, because not only they are posting the issue, sometimes they're also sharing their code that they are actually doing some interesting project over there. So the forum, I would say, is quite useful if you are using the DeepStream SDK. All this, you can see what others do and the project that they are running. Yeah.
Sounds good. All right. So we have another question. It's from Prai Somaldo from University of Indonesia. I've tried TRT toolkit to train deep learning, also optimize and pruning. Is it replaced by Tau toolkit since it can do similar tasks, or is it still maintained?
Yeah. So yeah, this is a good question. So the TRT, the transfer learning toolkit, is actually rebrand and is calling right now the Tau toolkit. So Tau toolkit is actually I would say the TRT is previously of the previous version of Tau toolkit. So it's currently replaced with this new Tau toolkit. So there are more features can be done compared to the previous TRT toolkit. Like just now, I've shared the QAT, the quantization aware training, all this. So there are more great features over there inside this Tau toolkit. So I would say if you are trying out something new, definitely the Tau toolkit will be the best. and then we are keep on rolling out new pre-trained model to support with the TAO toolkit, and also some of the great features are within this TAO toolkit.
Sounds good.
Okay.
So it seems the TAO toolkit is like a newer version,
Yeah,
updated version of the TRT toolkit.
Yeah.
Okay. Sounds good. So it's just more enhanced, more
Yeah.
advanced. Yep.
Yeah.
Sounds good. So, Mr. Chong, you mentioned that on the forum, you also saw some people share their great work, some models. So far, like, what do you think, like, some of the use cases that is really interesting that you've seen so far in the forum? If you don't mind to share.
Okay.
I guess it's a lot.
Yeah, there's quite a number of projects, but some I would say those segmentation model doing some defect detection, those are quite interesting project for me. Like one of the use cases that are sharing, although that one is not in the community, that one is a commercialized project. Yeah, is they track the winkers, right? I think I show the use cases that the bottle, and then they track the winkers of the bottles, and then yeah, this one is quite interesting. And also some of the defect detection that they do is on some of the PCB board that they track all these 40 parts, something like that. Yeah, so there are quite a lot of these interesting use cases that I feel interesting, but some others may not feel interesting. Maybe they are more towards those because AI is a very, I would say, a very huge and also very broad world, right? So some people may be expecting something like, is there any kind of like very strong AI kind of implementation? Is like those robotics, they are similar to human that, yeah, but we are still trying to evolving to that stage yet. So sometimes people I think robotics thing are more interesting to them, but for me, because I'm more focusing on the video analytics, maybe I'm more realistic. So I'm specific to all those object segmentation detection, all this, and particular to those use cases.
Sounds good. I guess personally for me, like everything about AI is kind of interesting.
Yeah.
There's a lot of things going on.
Yeah,
like,
there are a lot
of things to learn. But yeah.
So you see, the autonomous driving is another things that is pretty interesting, and also they're actually also using a lot of video analytics inside. Yeah. Yeah.
Okay. Oh, we have another question. So it's from Ahmad as well. So can we transfer learning a pre-trained model from other sources with TAO toolkits such as YOLO and some other popular network architecture, or is it only available for pre-trained models from NGs?
Yes, there are a lot of popular network architecture already in our NGC. Like you mentioned, the YOLO V3, V4, that we also have that. So inside there are 100 plus of the models. Those are the public models that you can use it for retraining with your own data set. So this one is available, not only our pre-trained model, but also some others are public or popular network architecture inside the NGC. Okay.
Sounds good. So another question is also from Pry. Another one is Tipstream can stream through modern front-end framework to visualize video on the web real time. This use case still on premise though.
Okay. You means can you pass the data back to backend and then visualize over backend? So in this stream there's actually have a plugin called OSD that you can run the visualization. You get a result, then the bounding box result, then you use this OSD plugin, then you can do the visualization. Another thing is you can use the message broker or any other communication protocol like the gRPC to send your data to your backend and then visualize at your backend. So there are multiple kind of ways for you to actually visualize the result, either using the plugins available within the Dictionary SDK, or you can send the output data, the result, to your backend system, so that your backend system can actually do back the annotation, the bounding box, encode it back the result to your backend. Yeah, so there are a lot of ways that you can do it. Okay.
Sounds good. Okay, any other question? Silakan, ada yang mau pertanyaan, boleh loh pakai bahasa Indonesia. Question, pertanyaan. Mungkin kita ngambil 1 atau 2 pertanyaan terakhir, maybe 1 or more 2 questions before people filling out the attendance form link that will be shared shortly.
Yeah, so like just now, Etikan mentioned, right? So just now I have shared a lot of things. I think everyone may need some time to digest all the things, like if someone is new to our software stack, right? The stream, the TOOLKIT, the Triton, yeah. So they may not have experienced it before. So to get everything done quickly is to make your hand dirty. So to try the hands-on. Yeah. Hands-on parts is actually can help you to understand the whole workflow, so that you understand what is the purpose of using this toolkit or the SDK. Yeah, so to get the developers have a deeper understanding, I would say, when they try it out.
Yeah, definitely get your hands dirty,
yeah,
right?
yeah.
Go to NGZ, install, and then trial and error, like we've done here. We're still in the trial and error process.
Yeah, because I myself was a developer before, so developers definitely will encounter different kind of issue, different kind of, could be a very minor issue that like library version doesn't match, right? Can be during your installation can take a lot of time. Yeah, so always trying to, but going through the experience, definitely you know what's going wrong.
Sounds good. I agree, totally agree.
Yeah.
Oke, silakan pertanyaan. Kita mengambil 1-2 pertanyaan mungkin. Oke, untuk sekarang udah di-share isi formulir attendance, silahkan diisi. So I've shared the attendance link on the chat, so feel free to complete the link, complete the form. Silakan yang mau menanyakan pertanyaan, silakan boleh angkat tangan, or if you want to put question on the chat. So Prai or Ahmad, if you have any more question to clarify, feel free to clarify. So we'll leave the attendance link for like a couple more minutes before we take it down. Okay. So thank you everyone for attending the webinar. Thank you, Mr. Chong, for the, oh, never mind. There's one more question actually. So it's from Prai. So some layers, when we convert models to TensorRT, still not support. Is there another easier way to convert to TensorRT?
Okay, so I will take this. So if you are, so because the TensorRT is a acceleration engine that is when you run the layer, you can get optimization inside our hardware. So to convert it successfully, some of the layer, if you use some, because basically most of the popular architecture that we have in the public world right now, so normally we have it able to convert. But if you are unable to convert, either you need to do a customized data set, customized layer set on the TensorRT, so that you can convert it successfully. But this one require, I would say, a lot of works to do, because you need the layers to be understood by the kernel layer of the hardware. So you need to use the CUDA library to build out all this layer. Another way to do is we actually, our latest version of TensorRT actually, if you are using PyTorch or the TensorFlow, you can actually run some of the layer natively in PyTorch, and then some of the layer in TensorRT. So you get to have a balance, like I would say a hybrid mode. So those layer that can convert it into a TensorRT, they will convert it for you. Then some of the layer that cannot, they will run it natively in the Python code, PyTorch. Yeah, so you can get to have both, and then this one will increase your performance in overall. And then another part is you can use the Triton inference server. The Triton inference server can actually help you to run multiple different native framework directly over there. So these are a few methods that is allowed for you to try out.
Sounds good.
Okay.
Thank you for the questions.
Yeah.
Okay, everyone, thank you for attending the meeting and then the webinar. Thank you, Mr. Chong, for the
Okay.
insightful information. Definitely a lot of things to digest.
Yeah.
So thank you for sharing that.
Okay.
All right, so thank you, and then stay tuned. We have another webinar for upcoming months, so everyone over here, stay tuned. So stay tuned for on the announcement, register, and then because another e-certificate will be provided. And then until then, good afternoon, everyone. Stay healthy and see you next time.
Okay. Thank you. Thank you, everyone.
you.
Thank you, Lina. Okay.
Thank
Thank you for everyone
you.
time. Okay. Bye-bye. Bye.
Bye-bye.